so my name is Jack Bruno. I am a senior in the Honors Tutorial College Physics program here at Ohio University. The topic of my research last summer was similar to what I'd done the summer before. I've been working with the University of Wisconsin-Madison for the past 2 years in collaboration also with Ohio University, studying ozone pollution transport over Lake Michigan, specifically on the Wisconsin side. So the predominant thing that we're studying was that there is really high city levels of ozone pollution in Sheboygan, Wisconsin, which does not have a city in it. So one of the key things that we found is that the numerical models that we use for predicting pollution transport are failing pretty significantly to predict the transport during lake breeze event. In terms of helping the research move forward, I'm writing my undergraduate thesis on specifically the thermodynamic modeling of lake breeze events. So I'm doing analysis of a series of model runs compared to remote sensing data that we took 2 summers ago to determine the best kind of modeling parameters for predicting this type of ozone event. So while I was there last summer, I worked under Dr. Brad Pierce, as well as in collaboration with Tim Wagner and John Giro, who were 2 other scientists on the project. And the really interesting thing about atmospheric work is it follows a lot of very classical rules, follows very Newtonian physics, but it does so in incredibly complicated, insane, weird ways. The applications of the work that I'm doing in the short term involve better prediction and early warning of ozone pollution events on the coast of Wisconsin. Longer term, they mean we might be able to implement more surgical and correct regulatory policy, and they might also help us better understand lake breeze pollution transport in all coastal areas, particularly lake areas, but possibly also looking at sea breezes. So ozone pollution does disproportionately affect groups. One of the things that I want to clarify really quickly is when people hear ozone, they think ozone layer, ozone hole, and that's not what we're talking about. Ozone in the upper atmosphere protects us from ultraviolet radiation. Ozone in the lower atmosphere primarily comes from nitrogen oxides that are produced in urban areas, and through a reaction driven by sunlight, you end up with ozone for short amounts of time, and that inhibits respiration. So elderly populations and asthmatic populations will see increased rates of respiratory failure. A lot of great researchers out in Colorado have done a lot of work on this, where they've got lower oxygen densities, so respiratory failure can happen a lot easier among these at-risk populations. So just broadly, better understanding ozone pollution, ozone transport helps us with regulating this type of pollution and giving early warnings to these kind of at-risk groups.